Chapter 24, Transition Metals and Coordination Compounds. The colors of rubies and emeralds. Yeah, beautiful, beautiful stones. Here's a ruby and an emerald. Rubies are red, emeralds are green. Very different colors, right? The color of both of these gemstones is due to the same ion. It's due to chromium 3+ ion. So in each of these ionic compounds, and that's what crystals are, they're ionic compounds, both of these compounds contain aluminum ions. And about 1% of the aluminum ions, if I remember correctly, that's a ruby. Ruby is iron oxide, and I don't remember the formula for the emerald. Aluminum oxide, about 1% of the aluminum ions are replaced with chromium ions, and that's what gives it that beautiful color. But how do we get two very different colors from the same ion? So it turns out that the atoms in the host crystal that are around the chromium ion create a field, an electric field around it. It's called the crystal field. And that splits the degenerate d orbitals of chromium into two or more levels. So normally d orbitals are degenerate. Do you remember how many d orbitals there are in each level? There's 10 d electrons and 5 d orbitals. They each hold 2. So 5 d orbitals, and they're equal in energy. But the crystal field causes them to split. And the color that we see in these gemstones is due to electron transitions between those levels. And so just like when we look at excited helium atoms or hydrogen atom molecules or mercury, and we see that emission spectrum, there's a corresponding absorbance as well. And the color that we observe in objects has to do with the colors that they absorb and the colors that they reflect. And so that's the different colors of these two gemstones is because the d orbital energy levels are split differently in these two compounds. And so we're going to learn more about that in this chapter.